Cool. So we have quite a bit to get through today. So like I said on last Monday, we're going to just recap what we learned about last week, and then we'll move on to the new subject. But before we get on to the new subject today, I noticed some of you had said that you've never touched Git before, you're not experienced with Git, so today we're going to actually do something that might be different for all of you, because unless you've worked with a version control system GUI, then today will be the first time you've ever touched one. So we'll probably download GitHub Desktop, and then we'll work through GitHub Desktop. This will do two things, actually. One, it'll give you exposure to a GUI, working with Git through a GUI. And then two, it will also allow you to be able to download my files each week fairly easily, instead of me having to put like a compressed version of my files up on Blackboard. All you'll do is do a pull every week. So you'll pull, and that'll pull down the new lesson, and you'll have the new lesson. So yeah, we'll do that after we do the recap. Then we'll be moving on to today's lesson, which will be basic syntax rules. So things like the terminating characters, console log, stuff like that, some basic stuff for JavaScript. And then arrays and loops. And then next week will be functions. So yeah, we're progressing along pretty good, actually. All right, so let's just recap. Last week we talked about variables and conditionals. Variables and conditionals shouldn't be new to you guys. You guys have done them before. There is some nuances in JavaScript when you're working with variables. Like, for example, are variables in JavaScript data types? No, right? Because they're implicitly data type. They're implicitly meaning that the value is assessed at runtime, and then they figure out what the data type is going to be at runtime. But you don't actually explicitly define the data type for the variable. You're not saying string my var equal whatever. Instead, you just, at runtime, it will automatically figure it out. That's because JavaScript is duck typed, right? Remember we talked about duck type last week? Walks like a duck, quacks like a duck, must be a duck. That's the whole idea of JavaScript. It is implied. All data types are implied. One other thing about JavaScript, you have 4 types of visibility when it comes to scope. And that is global, right? You have global scope, which is no modifier used to actually define the variable. You have functional scope, which is defined with var. And then you also have block scoped, and there's 2 versions of your block scope variables, and that is let, which is mutable, and const, which is immutable, right? So we talked about that last week. And there's the examples of each one. What else did we do last week? We did a lot of things last week. We talked about conditionals. We talked about comparison operators. These shouldn't be new. Maybe the only thing that's slightly different is that JavaScript has loose comparison as well as strict comparison. However, we don't often use loose comparison because it's kind of frowned upon. We want to stay with strict comparison. So the idea is to try to stick with the triple equal signs, the not equal sign, so that way you're not only comparing against the value, but you're also comparing what data type your values are, right? So that way 5, the number, is not equal to 5, the string, right? If you use strict comparison, then those things will be different. Then we also talked a little bit about logical operators. These shouldn't be new, the double ampersand, the double pipe, which stand for and or. That basically takes 2 expressions, and if it's the double ampersand, then as long as both expressions are true, then it will return true. If you use the or character, though, if one of the expressions is true, then it will return true. All right? All of that should be just a recap. You should have did that in your intro to programming class. We took a look at if-else and else-if conditions, which is the if control structure syntax, and we showed how to do that in JavaScript, which is the same in most languages. There's not really any syntactical difference between how you do that in JavaScript versus how you do it in any other language. I think the only thing that we talked about that might be slightly different is switches. Switches in JavaScript are fairly powerful. They're very versatile. They allow us to do a lot of crazy things. Like, for example, ignore the break statement, which will allow us to evaluate multiple cases against a value, which is pretty cool. And then we practiced. Oh, we talked about the ternary, one of my favorite shorthands. All right, ternary is available in JavaScript, is available in Ruby. You can do ternaries in C++, which is a pretty mid-level strict language. You can do ternaries in Java. You got to be able to, can you? Yeah. I've never done Java, so I don't know. You can't do ternaries in CoffeeScript, which is kind of annoying if you work in CoffeeScript. But you can do ternaries in most things. And the best thing that ternaries are used for is toggling, right? When we want to toggle between two values, ternaries are fantastic for that kind of idea. As you can see demonstrated by our light switch, which was the last thing that we did in our practice. So I marked the labs that were handed in last week. And yeah, they were great. For the most part, they were absolutely perfect. So I think we can progress without too much recap. If you do have any concerns that you're slipping behind at all, please let me know through Slack. That is the best place to contact me. Otherwise, through email. I am here an hour before. Today I was here at 5 o'clock and I played Diablo till you guys got here on my Switch. Best birthday present ever was the Switch. Yeah, so other than that, feel free to come bug me. I'm also here Thursdays between 5 and 7, so I'm here for like 2 hours with nothing to do. So if you need any help or any support, not even just in this class, I've done a lot of programming in a lot of different courses in a lot of different languages, and I've taught quite a few classes, a few different subjects actually here at Georgian. So if you need help in any other subject, you know, like I said, I'm bored for 2 hours. Yeah, bet.
Did you play your Switch on the projector or on like a monitor?
No, I want to get one of those cables because I'm not going to walk around with the dock. So, yeah, I wouldn't mind getting a cable so I can throw it up there and play it on there. But, yeah, no, just, yeah. Handheld Diablo, that was like the best thing. That was the whole reason why I bought it. All right. Also, I'm not sure how many of you actually watched the video, but I do record the lessons. I posted it. I was pretty good last week. I posted it up on Tuesday morning. I just compiled it at work and sent it up online. So if you are behind it all, feel free to join the YouTube channel. The link is underneath the week lesson. So if you go to weekly lesson, week 1, you will see at the bottom, I'll post the YouTube link inside the lesson. The easiest way to do that is to go to the first one, subscribe to the channel, and then after that, every time I post a new video, you'll automatically get a notification letting you know that the new video has been posted. Definitely the easiest way. I had one student last semester refuse to do it because he said he didn't want me to make money off of it. I'm not going to get enough views, so it's definitely not worth your time. All right, so let's talk about today. Any questions about last week's variables or conditionals before we move on? It's a recap, right? Like it's just, yeah, that's what I thought. All right, cool. Like I said, today we're going to talk about basic syntax, arrays, and conditionals. But before we do that, we're going to get into this wonderful thing called Github Gui. Github Gui, I really don't care what GUI you use. If you're comfortable with like Atlassian's source tree, you're welcome to use that. If you own a Mac and you want to use Tower, go for it. But this is cross-platform. It works on Mac OS and Windows, and they are releasing a version for Linux, which is fantastic because currently I use Kraken and it sucks. But basically what it is it's an interface, like an application, right, that goes on your laptop. So instead of you doing, Git commands through the terminal, you can actually use this thing to easily interact with repositories online. So for those of you that don't know what version control is, the idea behind version control is that when you make a modification to your application or your files, it doesn't even necessarily have to be applications. Some people use version control for writing books, doing like revisions on tests, doing revisions on graphics. There's like tons of things you can use version control for. But the idea is that the difference between the file when you start with it and the difference between when the next version of it is not that much, and there's no reason to duplicate your file entirely. So what version control gives us is it only saves the changes that have been made between the first time you touch your file and the next time you touch your file. And it keeps a history of that. So every time you make a modification and you commit those changes, it keeps a history of those changes. So if you make a mistake and you go, well, I don't really want that change, you can roll back in time to a previous version of your file. And the cool thing is, because it's not an entire duplicate of the file, it means that you're not storing like massive amounts of data. You're only storing just the change you made, just minuscule amounts. Sometimes it's only a couple of lines that you might have changed inside your application, and you're only saving that couple of lines. Now, a lot of people confuse version control with just GitHub. Like, yeah, I've got GitHub. Yeah, totally, I've got GitHub. GitHub is not Git, not directly. Git is a version control platform that you can install locally on your computer, and then that allows you to have version control locally on your computer. GitHub is an online repository. It allows you to take the content that's on your computer and create a backup of it online, right? Just like cloud services like Dropbox or Boxy or Google Drive or any of those guys. It's the same kind of idea. You're just taking a version of your application and storing it online, and then using GitHub to basically create a backup. But the actual version control system can run locally. It can run online. It can go wherever you really want to download the application and run the application. All right, so let's start off with the first part. We'll all sign up for GitHub if you don't have it. How many of you don't have a GitHub account, out of curiosity? Okay, so let's go to GitHub. Just go to github.com. Once you get to github.com, hold on, let me sign out. So you can see what so I can see what you see. Because they change the interface all the time. Any day now. The internet's kind of shaky tonight, by the looks of it. Perfect. All right, so you should see this page here. There's a sign up. It automatically takes you to the sign up as if you're a brand new user. Enter in your email address, your username, then your email address, and then your password. Now, the username is important that you keep track of it. Don't forget your username because you use your username when you want to authenticate. So you need a username. I would use your Georgian email address because you get perks. And then come up with a password and click sign up for GitHub. And it'll take you a few seconds to get in there. The rest of you can go ahead and sign in if you haven't already. None of those are me. This is one password, and of course it's not in there. So once you've signed up or signed in or whatever, you usually hit your dashboard. This is your dashboard here, and your dashboard gives you a little bit of like quick view information, like the most recent repositories that you have, any issues or pull requests you might have. I imagine a lot of you don't know what issues are or pull requests are, but that's totally fine. We're not actually going to use those anyways. I'm not going to create pull requests or anything like that. If I find at the end of the term, though, that we have some time, I might show you some more common things that you will see in GitHub, especially when you guys go on co-ops and you're working at companies that use GitHub. There are definitely some things that you should know how to do, like forking, creating your own branches and stuff like that, and working in your own development branch, and then doing things like pull requests and merges and stuff. For now, we're just going to keep it pretty simple. All right, so for this, You can create a new repository if you want. It's totally up to you. You don't have to, but it is good experience. All you do is beside the repository thing there, it says new. If you click on new, you can give your repository whatever name you want to give it, right? Probably not a bad one right now. Would be comp 1073 dash. And why don't we call this assignments dash 01. There you go. Then you'll have it, right? It'll be like another 2 weeks before I actually issue it out, or no, it'll be next week. Next week I'll issue it out. But you have until the end of the term, so it's like 3-4 weeks. Anyways, let's go ahead and create that. Before we do that though, I do recommend initializing the repository with a README. And GitHub has just released private for free. So now you can actually have a private repository completely for free. Not that it matters, because if you're using GitHub through Georgian College and you've got that wonderful package with it, you guys get free repositories anyways. And you have to think of it from like a academic misconduct approach. Keeping your repositories free makes sure that people don't steal your stuff, right? So it's definitely worthwhile keeping them private. You can add a license or not. It's totally up to you. But definitely initialize with a README. It makes it a lot easier to clone it down. Anyways, when you're done, just click Create Repository. And that's going to chug away. And then bam, you have a repository. If you actually want to fill out your README, you can. It uses markup, which is like a very simple language to program in. It might take you like 30 minutes to learn it. But you can create your own README for your assignment at the time, though it was not ever required. All right, step 2, let's download GitHub Desktop. So if you go to GitHub Desktop, if you're on Windows, it should say download for Windows. It should detect, right? If it doesn't, just underneath the download for Mac OS, there is a download for Windows there. So go ahead and download GitHub Desktop. I'll give you a few seconds to do that. Now, if you're totally comfortable with the terminal and you prefer to just use the terminal, that's totally fine. I'm not going to tell you have to use this by any means. You use what you want to use. Kind of the same idea with the IDE. I don't care what IDE you use as long as you can code. That's all I really care about. All right. Might take a few seconds. I'm not sure how big the file is. I'm not going to re-download it because I already have it. Once you get it, though, go ahead and open it up. When you install it, if you don't have Git locally on your machine, it should install Git for you, the package for you. And install it in the background and make it accessible to you so that you can use Git locally if you choose to. Once you have it, what we want to do is we're going to actually access the modules that I've put online through Blackboard. And in order to do that, we're going to use clone. What clone will do is it will take a copy from online and copy it down to a directory you choose to copy it to. The benefit is that every week when I post a new module, all you'll have to do is pull, and the module will come down to your computer, and that's it. You only get that module, though. You don't have to actually, that way you're not downloading the zip every single week, which is just going to give you multitudes of files, right? You only need the one piece, so you only need to pull what's changed. So, in order to clone, we're actually going to need the link from GitHub. There we go. So you can get there if you go to our weekly learning and you click on the modules link. That'll take you to the GitHub page. Okay. And on the right-hand side, you'll see the clone or download green button there. If you click that, you get two options, open in desktop or download zip. You can open in desktop, which would open up in the GitHub's desktop app. Or you can click this little clipboard icon, which also works. So you just click the little icon. That copies it to your clipboard on your computer. Then you click the clone a repository. If you don't have this view, you can go up to where it says repository. No, where is it? Oh, sorry, it's under file, and you can go to clone repository there. Okay. Now I did try to do it where I pasted it in, but it didn't really work. So if you go to URL, you'll see the three tabs at the top. One says URL. Just click on that. Paste that link in there. And then choose where you want it to actually save the files. Okay, I'm just going to throw them on my desktop just because it's simple enough for me to do that. I would recommend putting them somewhere more permanent for you guys. And then once you've chosen a directory where you actually want to save those files, go ahead and click clone. And then what's going to happen is it's going to take the files that are currently on GitHub, it's going to move them to your computer, we'll copy them to your computer, and then you're yay. You have all the modules. So I'll click clone. It takes like not even 10 seconds because they're not really that big. They're quite small. And we're good. So when I make the change next week and we have module 3, what we'll do next week is we'll pull module 3. And I don't expect you to remember this between now and then, but the way we'll do that is we'll just go to the word repository, and we'll just click pull, and then that will pull whatever changes are currently live on my GitHub account and pull them down to you. So that way you're always up to date, right? Much easier than downloading a zip of the module and decompressing it. Much easier than dealing with file allocations and stuff like that. Also cuts down on the amount of redundancy as well. All right, cool. Now, the one thing to note, the lab you guys did last week, those JavaScript changes that we made last week are not going to be in this repository. Okay? So what you may want to do is take that lab file, that main.js, copy the contents out, and paste them into the module 1 main.js so you have them. Okay? If you want. Totally up to you. Doesn't really matter. All right, cool. So if that is all good, and you go to your Explorer, and you go to Desktop, you should have a folder that says Comp 1073 Winter 2019. And if you click on it, you should see that you have an assets directory, an index.html, a module 1, and a module 2. If we have time next week, I'd really like to teach you guys how to install Live Server, because it will make your lives very, very simple. Basically, as you make a change to any file, it immediately updates in the browser, which is fantastic, right? However, it's quite involved because we have to install NPM, and we have to install Node, and then we can install Live Server. That being said, for now, if you take that index.html that's in the root of this folder, and you drag that into your browser, like so. Whoop, don't do it on the GitHub thing. It appears GitHub wants to do stuff if you do it that way. Do it on a fresh tab. You'll see that you have 2 links. It's not very pretty. I ran out of time on the weekend. I'll pretty it up over the week. But for now, you got 2 links. They're pretty direct. Just click on the module 2 link. That might do this. If it does this, just click on the index.html link. And you should see this if everything is good. All right. Now I'm going to use Live Server. but that doesn't affect you in any way. It just means that I don't have to constantly refresh my screen. All right. So I'm going to dock this left so that you can see it. It is kind of hard to see, but you guys are following along anyways. I'm going to open up my IDE like usual. And inside my IDE, I'm going to go to File, Open, navigate to my desktop where I have that folder. And you can either open the whole folder if you want, it doesn't really matter, or just open up Module 2, right? And I'm going to open that on the right-hand side. And I'm going to work in the main.js file. Okay. So once again, I'm opening up my Module 2 folder that I downloaded into my IDE. And I'm going to work inside the main.js file. Cool. Can everybody see that from back there? Is that big enough? Yeah? Cool. All right, so this is interactive too. This week I'm trying to actually develop something that will allow me to use regular expression to evaluate what you type so I can kind of help you with your syntax, right? So then I can evaluate your syntax and make sure your syntax is correct and give you live feedback on your syntax as you type it. But yeah, give me a little bit for that. Just having some issues with being able to fetch a file into the client. And I don't want you guys to have to download huge environments just in order to do this, right? I want it to be fairly simple. So I will be working on that. However, for now, it will tell you if your variables are correct. It'll tell you if they're block scope or not. It will tell you if the data type is incorrect. And it will tell you if the value is wrong. Okay, so that's about as interactive as we get right now. That being said, we're going to talk about some basic rules. There is one rule I kind of missed in here. It's not really a rule. It's a basic syntax, and that is concatenation. But when I get to that, I'll explain it. I'm sure you guys have done concatenation. Does anybody not know that word, concatenation? Yeah? Okay. We'll talk a little bit about concatenation in JavaScript. Essentially, it's just combining strings together, right? Values and strings together, and we'll take a look at that. But it isn't, unfortunately, in this lecture note thing. All right, so let's talk a little bit about the basic rules. One of the most common rules right off the bat is the semicolon. And there's some mixed information out there when you're looking up JavaScript syntax. And that's that it's implied that the semicolon is implied, right? So, for example, I could do let my fave foods and drop the semicolon, and that is completely syntactically correct. The browser won't explode, it won't get mad. And I can show you that if I back this out. Just going to open up this for a second. There we go. And I'm just going to refresh. And you'll notice that I've got no errors, right? There's no errors appearing or anything like that. No big red, pink blocks or anything. And the reason is because the semicolon is technically optional. However, what I will say about the semicolon, the way JavaScript reads is line by line, and it will logically terminate the line if it thinks it's terminated, right? So it will go through and go, cool, let my fave foods. All right, the next line is let MMF, so it's like, cool, I see the word let. That means the line previous should be terminated. So it immediately implies that the line is done. The statement is executed, it's fine, right? The problem is if this next line is a global variable, or if it's a function, or if it's, what else is there? There's a few different syntaxes that can lead to let my fave food thinking that the next line is technically the value that's supposed to be assigned to it, then it will explode. Basically, in a nutshell, we're going to use semicolons to terminate our lines. Okay? That way we don't wind up with any crazy, strange things happening to your code. Makes your code readable. It's easy for you to know what's going on. You don't wind up with weird errors that are going to lead you down a massive rabbit hole. Okay? So we'll use semicolons instead of dropping semicolons. However, if you take my Node class in September, we'll be dropping semicolons because we don't need them. Node takes care of it for us. But anyways, for now, yeah, we'll be using semicolons. So that's one of the important rules in JavaScript. Just makes life nice and easy for you. And the way semicolons look, you've seen it before. Let x equal 5 with a semicolon. It's basically the thing that terminates the statement. It's what tells the interpreter that my statement is complete. Just like you use a period in a sentence, it's no different. It's like the period for programming, essentially, right? You have semicolons in Java. There's semicolons in most languages. C++ has semicolons. Ruby does not. You don't need them in Ruby, but you can. You can if you want to, but it's not necessary. But most languages have semicolons. C# has semicolons, languages like that. All right? PHP, definitely semicolons. It blows up if you don't use them. So it shouldn't be anything new. That should be a bit of a recap. Assignment versus comparison. I'm only mentioning this because a couple of the labs had this glitch. There is a difference between when we're assigning a value to a variable and when we're comparing a value to a variable. Okay? So, for example, a lot of people like to do this kind of thing. So they'll go if. If automatically implies that you're comparing, right? It's a conditional syntax, right? And then they'll go x equals 5, and then write their block. Okay? Does anybody know what this evaluates to? Yeah?
X being 5?
It does. I'm looking more for the Boolean value. Does anybody know what the Boolean value of that will be? Yeah, it'll be true. The reason why is because you explicitly have to state false if you want it to be false. That's cool. A lot of people do that. A lot of people will just pass the value, right? Because true is true, true is true, 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 right? Unless I'm going to explicitly state false, then I can kind of get away with shorthand. The problem is if you use a single equals operator, what you're basically saying is x is equal to 5. So you're essentially assigning this to x. Then you're evaluating 5, which is true. And then you're executing your code in here, which you may not have intended, right? What should the operator in the middle be? Yeah, Ben? 2 or what would be better? 3, right, because strict comparison is definitely better than loose comparison, right? So that is a gotcha for some people. That being said, I've yet to see a programming language where a single equals is a comparison. So hopefully that's not a gotcha. I think the reason why is just, first class jitters, right? Make slight mistakes. That's totally cool. But just keep that in mind. Assignment operators versus comparison operators, they are very different. All right. Commenting. This is like handy, right? You always want to make comments. Now, you've seen me do the commenting. That's what these double forward slash. It's forward slash, right? If it's pointed. It's always the direction it's kind of like leaning towards. Yeah, so it's forward slashes. The double forward slashes are they're a single line comparison. Or sorry, a single line comment. So, that's single line. If I was to go here afterwards, that would cause a syntax error because that's not technically wrapped in the comment, right? If I want to do a multi-line comment, I have slash. Oh, this is going to be terrible. Please don't make fun of me. There we go. There's my slash. Multi-line. And then you just mirror it on the bottom, right? Is Java the same for multi-line and single line? Yeah, I kind of figured as much. So that's basically it. There are things like EOS, which you might come across. EOS is, I can never remember what it means. I think it means end of string. But basically it allows you to do a big block. that's encapsulated, but we're not going to really get into EOS. But for now, single line, multi-line, let's correct this syntax. There we go. Cool. Commenting is pretty simple, right? Any questions about any of that syntax? No? Anything new? No? Okay. So the last thing that is not written down here that I want to talk about is concatenation, because we will be using it today, but I kind of forgot that I should actually teach it first. So concatenation is essentially used to basically take different values and combine them together, right? So that you can create one string. And actually, I think it might be easier to do it in here. So I'm going to open up my console. And you don't have to do this, so just watch what I do, I guess. There we go. I'll clear it out. And I'll zoom in a bit so that you can see what's happening. Why is this silly thing? There we go. I mean, there's no errors if you shut them off, right? There's nothing wrong when you can't see it. Okay, so concatenation. So let's create a variable. Let age equal 40. Okay, so there's my age, right? And then I'm going to say let name equal Sean McKinnon. Okay, both like let name could be a const, right? I'm not likely going to change my last name at any point or my first name, but whatever. So I have age and name, and now I want to write a sentence that says Sean McKinnon is 40, but I want to use the variables, right? So it's dynamic. So in order to do that, I'm going to say let, why not bio, right? Bio works. Let bio equal, what I want to do is what's known as concatenation. I want to take name and combine it with age, right? And the cool thing about concatenation, probably one of the easiest things for you to learn, because it's essentially the same as addition, right? When you add two numbers together, it's really not much different, only this time you're now adding two strings together. Yes, 40 isn't a string, but the second we try to add it to a string, it immediately becomes a string. It basically auto-casts to a string. So to do that, I can say name, right? So now I've got name there. And now I want to say is, right? So I'm going to need a string in the middle. So I'll use what's known as a string literal, which just means you wrap it in quotes. So is, like so. And then I want to add 40 to it. There we go. And then I'm ready to terminate. Okay? And I know it's correct because it says undefined. There's no big error. So now I'll just type out bio to see what it says. And there you go. There's my concatenated string. So concatenation is done with these wonderful little plus signs. Makes life really simple. Next week, I think? Next week, we're actually going to look at something called string interpolation. String interpolation essentially looks like this. It uses the backtick characters, which I think I mentioned last week is a form of quote. And it does the same thing. But you get to write it in line. But what's even cooler about that, you can evaluate expressions in it too. So it's pretty smart. But we'll do a bunch of practicing with the backtick string interpolation next week. So that's concatenation. I'm pretty sure concatenation in Java is the same. It's with the plus signs. It's the same in C, right? So C and C++ use concatenation the same way. PHP is the same. No, PHP is with dots. But most languages are with plus signs. All right? Cool. Do we need a break or are we ready for a raise? Ready for a raise or you want a break? We're good? I mean, you're going to get outvoted, right? Yeah. All right, so introducing arrays. You guys have used arrays. Anybody not used an array before? Cool. That makes life nice and easy. However, arrays in JavaScript are a little different than arrays in Java. They're closer to, I would say they're closer to lists because they're dynamically sizable. You can make them as big as you want. You can make them as small as you want. And you don't have to predefine their data size or their data type at the time of declaration, which is super awesome. You just use them. You just use them however you want. They're essentially a list of items, right? That's what arrays are. They store a list of data. Most strict languages, these lists are usually the same data type. However, in JavaScript, arrays can be composed of many different types of data. So you could, in your array, store Sean, the number 40, the Boolean true, and another array, all in the same list. And it won't blow up. That's totally okay. JavaScript's like, yeah, man, go for it, right? We don't commonly do that, though. We commonly try to keep the data the same, right? Because when it comes down to normalization, right, we want to make sure that normalization implies that everything is the same. It's easier to work with data structures that are the same instead of mixing them around. But you can. You can mix your data. That's totally fine in JavaScript. It doesn't care. All right. The array syntax in JavaScript is very common to other languages. The instantiation of it can be slightly different. Like, for example, in C++, if you want to create a new array, you would have to state what the array is. Can't use string, but we'll use car. So we'll say car X. Then you have to either state how many are in it, right? So I'm going to say there's 5 values in it, right? And then you can list the 5 values if you want to, or you can just predefine this, like so, right? That's how you would do it in C++. Java's probably not far off, right, when you're defining an array. Most strict languages require you to define the data type, the name of the variable, and the size of the array. In JavaScript, the syntax is close. Not exactly the same, but it is close. So in JavaScript, what we can do is we have to define a variable. Well, we don't, actually. We can use the array just as is. We don't actually have to store it. We can use what's known as a literal array if we want to, which is just an array that isn't stored in a variable. But if we want to actually be able to access it later on, then it's a good idea to put it somewhere, usually in a container like a variable. And the syntax for it is very simple. We need our variable name. Usually we're going to precede that with a scoping modifier, right? So we'll say let my array, right? This is the same as any other variable declaration we've done, only now, instead of assigning it a string or a Boolean or a number, we're actually going to assign it an array. We start off the array with a square bracket. That syntax tells the interpreter that the next things following it will be a list of items. You can do that, which it basically says, hey, my R, or my array, is equal to an empty array, which means I've got nothing in it, but I can add things to it later on if I so choose. Okay? Or you can predefine it with some values. So like I said, you can put a string in it. You can put a number in it, a Boolean, right? Or another array. That is completely valid syntax in JavaScript. So you'll notice in the example here I have a names array, Sean, Bob, and Dave, right? And often when we store items in an array, we usually want to access them, otherwise the array is entirely pointless, right? So to access the elements inside the array, it's fairly simple. If I want to access Sean in the myR array, I simply write out the array, and then, exactly, 0. I reference the index number that my value is at. Now the values inside an array in 99.9% of languages are what's known as zero indexed, meaning the number they start at is 0. The index they start at is 0. So Sean is 0, 40 is 1, true is 2, and this nested array, the entire thing, is 3. Okay? That can get a little confusing for people starting out with arrays, but it's very important to remember that arrays are zero index, meaning they start at 0. So to access Sean, like somebody said, square bracket, 0, and that will return back Sean. If you look at the example, it shows the same thing. I'm going to zoom in a little bit more. There we go. As you can see, it says our variable with the array inside of it. Then we're returning back names 0, which will output Sean. If you want to output Dave, Dave lands in index 2, right? Which would make Bob index 1, right? Is that new? No? Cool. Arrays are zero indexed, meaning if you want to access the first item in an array, you have to use 0. This is common in most languages, and it hopefully shouldn't be new. So why don't we practice? Let's create our first JavaScript array. So I'm going to zoom out a little bit, because it's definitely a little bit more, there we go. Kind of goes off the screen a little bit, sorry about that. All right, so step 1. Let's assign the provided variable a 3-item array. Make all 3 items your favorite foods. Okay. So I've already provided you the variable, let my fave foods, right? I'll give you a few seconds there. The example is just above it, right? So just take a look at what we did with names and kind of copy the same idea there. But put favorite foods in it, right? I don't know. Okay. What's the first character I'm going to need? Equal sign, right? We want to assign an array. And how do I tell the interpreter that this is going to be an array? What's the syntax I need? Yep, square bracket. So we'll start off with our square brackets. Right now our array is empty and I want to put a value inside of it. So we'll add, I don't know, what are my favorite foods? Bacon, definitely bacon. There we go. Bacon's a good favorite food, right? I want to add another item. What piece of syntax do I need in order to add a new item? Yeah, we're going to need a comma. Just so you're aware, JavaScript does not support something called trailing commas. Trailing commas is where you leave a comma in your list and you don't put anything after it. That's known as a trailing comma. That will blow up. It will explode and JavaScript will get mad and yell about it. Okay? So it doesn't support trailing commas, just to warn you. So we have bacon. What else do I like? I like cheesecake. All right. And I like pasta. Oops. There we go. So there's my list of items. If you did it correctly, it should update and show you your list of favorite items. Now, interestingly enough, JavaScript is pretty cool and liberal with how we structure our data. Right now, we're doing this all in one line, which to me kind of removes a little bit of readability. It makes it a little harder to read, especially if your line keeps going and you have word wrap on like I do. So it just kind of like pushes it, and it's hard to understand what the structure looks like. So what JavaScript allows us to do is it allows us to multi-line our arrays if we want to. And the way we do that, if you put your cursor just before the first quote character and hit enter and tab, you can actually move these things to other lines. Put cheesecake on the next line, pasta on the next line, and we'll move our closing bracket to the end. Yes, Ben?
If you're doing that, you still need the comments.
Yes, you definitely still need the comments because it's still a list. You're actually not changing anything about the syntax. JavaScript is simply ignoring the new lines. But it definitely is, to me, a lot more human readable. Makes it easier to see the list. Makes it easier to see if you have a trailing comma accidentally. It's definitely easier to look at. I find. If you want to keep it on one line, go for it. Totally up to you. So we assign the provided item our 3 pieces of data. Yeah.
So I did that, and I just have cheese, bacon, and cheesecake. Yeah.
What's that?
It's updating to your thing, not ours.
Oh, you have to refresh.
It's different.
It's like you initialized it before, and it's reading yours and putting that one instead of ours.
Yeah, you expect it.
Oh, really? It's not actually giving you your data, it's giving you my data? Alright. Yeah, no, I totally know why. Alright, so in the background, there's a JavaScript file that's running in the background. It's called evaluate.js. And evaluate.js, what it does is it assesses what you've written here and verifies that it's correct. And then it spits out the line here based on that. The problem is that the line is hard-coded. It's hard-coded with bacon, cheesecake, and pasta. And because of that, that's why it says cheese, bacon, cheesecake. It's just a bit of a hiccup with my evaluate.js, that's all. At the end of the day, though, if you really want to see it, you guys want to see what you wrote? It's not hard. In your browsers, right, you have this thing called developer tools. We're moving on a little bit ahead because this is further down. Actually, it's the next thing we're going to talk about called the Mighty Console. I'm going to expand my browser so it's full screen. The console is probably, hands down, the most beneficial thing you're going to work with because the console is essentially your debugging utility. It's what allows you to debug your code. Okay? So you can actually spit out values, you can see things that you've done, you can test code, you can write snippets right directly in there. Remember in week 1 when I said you can write JavaScript directly in the browser? That's done through the console itself. So to access the console, I've written a little table here that tells you how to access the console in your browser, in your particular operating system. If you're using Chrome and you're on a Mac, it's Command-Alt-J. That will open it up. If you're in Windows, it's F12. F12 on your keyboard will open up your console. If it doesn't, and it instead turns the volume up, you need to hold down the Fn key on your keyboard and then press F12. It just means that you've overridden your function keys. Okay? If you open it up, it's likely going to look like this, docked over to the other side. That's usually the way it works. If it doesn't look exactly like mine and instead looks kind of like this, you'll notice there's these tabs at the top of the console. There's elements, there's console, there's application, and then there's a set of double arrows that have a bunch of other pieces in there as well. You want to click on the console one. That'll open up the console for you. Right now it's loaded with a whole pile of errors. Those are custom errors that I've written. As we go through the lab, those errors will slowly disappear. Each one will just disappear as we complete the actual syntax. Okay? To check what we actually did with the variable that you wrote, you can type in my fave with a capital F, AV, capital F, OODS. And you should see what you wrote spit out to the browser. It shouldn't be replaced. Yeah. Which browser are you using? That's your operating system. Which internet browser are you using? Opera? No, I don't support Opera. Chrome, Firefox, Edge. Any of those 3 are totally fine. Opera is, don't use Opera. Opera breaks and everything. Opera's good for Nintendo DS.
I don't have an issue with it. Basic question is why it says 3 and 0 and
Right, because the 3 is actually a representation of how big the array is. It's how many items you have in your array. This little 3 that's written beside your array means the size of your array. It's how many items you actually have in the physical array. However, if you click this little arrow right beside it, you'll see it starts at 0 index, and then it moves down to 2. So you can actually visually see your array. That becomes really handy when we start talking about objects, by the way. This console is your best friend. It will show you your errors. They show up in pink whenever there's a problem. Like, for example, if I say, let's do let h equal 5, and then I say let h equal 10, I get an error because I'm not allowed to overwrite it. So I get uncaught syntax error, identify h has already been declared. These little pink errors, they're important. They tell you a lot of valuable information about what's happening with your program. It tells you the error message of what's wrong, and then over here it will actually give you a line number for where it's wrong, so that you can easily go look at your code and find the line where the error message is, and then correct whatever that problem is. All right. That was a rather in-depth explanation for why your array doesn't look like your array. But at least you get the idea. Okay, cool. So step 2. We're going to access the first item in the array. Now this is going to work kind of bizarrely, because when you go to access the first item, it will likely return back your first item. So it won't necessarily match up. But in order to access the first item, I'm going to go equals. I'm going to write out the name of my array, right? And then I want to access the first item in my array. What index am I going to use? 0, exactly. Oh, actually, I just showed the syntax. That's what I showed. Now I want to access the last item of my array. What index number is the last item of my array? Exactly, 2. So equals my fave foods 2. And then that's the last item of our array. So that's how we create a basic array. That's how we access the elements in our array. Very simple, not very difficult. Should be fairly similar to other languages that you've worked in. Yeah?
So why doesn't it just say let MLF last equal cheesecake, for example?
Because I'm showing you the syntax. Why don't we go back into our handy console again? Let's open up the handy console. Every time I say console, it sounds like a dirty word. It's like so close. All right, so when we want to look at the array itself, we just use my fave foods, and we can see the array inside our console. It makes it very easy to see what currently is in there. If I want to access an element inside there, it's no different than typing in my IDE. It's exactly the same. I can type code in my console. I can type code in my IDE. It doesn't matter. The cool thing about typing it in the console, though, is that I can see interactively, immediately interpret. Okay? So if I want to access the first item, my fave foods, 0, it will return bacon. If I want to see the next one, 1, it will return cheesecake. And if I change that to 2, it'll return pasta. Yours should hopefully return something different.
Okay,
Yeah.
it does.
Cool. The console is very handy. When I find a lot of students have issues with assignments, for example. I'll hand out an assignment, and it will have steps, right? And they'll go through the steps blindly, and they'll try to complete each step. And they won't test any of the code. They'll literally start at step 1, write all the steps out till they hit step 13, try to get it to run, zip it up, and send it to me. Because it won't run. The best thing you can do, the cool thing about the console is if your script goes into an error, right? then you're not going to be able to see whether or not the rest of the script is running. What you can do is copy chunks out of your script, paste them directly into the console, and run them. So that way you can easily see where you've gone wrong, what thing is actually erroring out, where there's the problem, so on and so forth. The console is fantastic. It makes your life a lot easier. We are going to look at debugging next week and actually using the debugger that's built into JavaScript, which will actually even further help your debugging when you're working with this language. Okay? Cool. I'm going to close my console. All right. So the JavaScript console is a way for us to debug our code and review our output. The console is tremendously powerful and crucial to being a good JavaScript developer. In order to output information to the console, we must learn an important command, the console log. Console.log is a fantastic tool that we can use to be able to output values from our IDE to that console window directly. So we can actually add console information into our IDE in our script, execute it, and it will spit it out to that console window for us using the wonderful little shorthand of console.log. So I showed you how to open up your shortcuts. If you're still having issues, there is a thing here. Unfortunately, browsers I don't support. I do not support Internet Explorer because it's dead and you shouldn't be using it. Okay, it's been dead for 2 years. Stop using that browser. And Opera. I don't support Opera because it's an edge case browser. And then there's another one too. It's got like a German name, but I can't remember it. But some people use it. I've had a few students use it, and it's bizarre. But anyways, the browsers that I recommend using when you're doing JavaScript development are Chrome. Yep.
Is it Aldi?
No, it's not Baldi. What's that?
Lucy?
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 No, it's not UC. It's very German sounding too. It's like Gladwitag or something like that. I can't remember what it's called. Anyways, the ones I support are Chrome, which make up currently 80% of the market right now using browsers. So 80% of the market that's using the internet is using Chrome. Okay? The other 20% is divided up amongst Firefox and Edge, and a very small, less than 1% is using Internet Explorer, Opera, and other. Oh, it's Console. It's with a K. No, it starts with a K, but it's not Console. It's something like Console. But what's that?
Kaiser?
No, it's not Kaiser. So anyways, I recommend for the best support, use Chrome and Firefox. You're less likely to have issues with your browser. If you choose to use one of the other browsers, you're on your own. All right? Okay, so open up the console inside Chrome or Firefox. Firefox does have some very cool debugging utilities for JavaScript. I've had a lot of students prefer Firefox over Chrome. Yeah.
Is it Koreakos?
Is it what?
Koreakos?
Conqueror?
Conqueror. That's it. It's Conqueror. Yeah. It's a bizarre browser that used to be on old flip phones, too.
It was made in 2008, if you're curious. It's on the Wikipedia page.
You can download it and try it. Your life is likely to be difficult, but yeah. All right, so why don't we actually practice with a little bit of console log. So console log is fairly simple. If you want to open up your console again so that you have it open. It's a bit meta, but you can write console log in the console. So you can type in console.log. I'll zoom in so you can see it. And then you can put whatever you want in here. You can put 5, you can put true, you can put an array, you can put an object, or you can put in a string. I'm just going to write hello world in it. And if you hit enter, and you did the syntax correctly, it should say hello world. Console log is neat because it can accept a list, only you don't have to define it as an array. And the cool thing about that is you can actually say, I want to console log these 6 different things. And to do that, we can go console log why don't we put 5, comma true, comma your name, comma, let's create an inline array with the values of 5, 6, and 7. And then we'll close it out. Just make sure you put a comma between each item. And when you hit enter, console will spit those out as the data types they are. 5 is a number, true is a boolean, name is a string, and you'll notice that the 5, 6, 7 is a proper array that you still have the interactive tool with. Console log is very cool. Very, very, very cool. All right? So we can actually work with console log directly within our IDE, like I said before. So I'm just going to pop open the IDE here. I'm going to scroll down to where it says step 4. Let's work in the console a little. So if you open up your console and copy and paste the message into the provided variable. So I'm going to have to refresh because I've done so much stuff in here. There we go. And it should be written somewhere. Oh, it's at the very top. At the very top, you will see the console message. The falcon flies south for the winter. It's spy speak. You know, like when you go to the park, you meet the person, and they give you the briefcase because you say that word? No? Okay, whatever. I think that's the exact reason. All right, so go ahead and copy that. Make sure you copy it verbatim because my evaluate.js evaluates based on the being verbatim. Verbatim means equal to, strictly equal to. All right, so beside let the console message, we're going to say equals and paste that in place. And is that correct? No. Yep, we need to quote it. Something interesting if you're using Sublime, you can highlight all that text, hold Shift, hit your quote key, and it will wrap it in quotes immediately for you. Hey, your first Sublime tip. You can also do it with single quotes and backticks. All three will work.
I'm sorry, what?
Backticks. Below your escape key underneath the tilde. Yep, that's a backtick. And if you did it correctly, it should update on the left-hand side with the falcon flies south for the winter. I think once we're done in the console, we'll take a break because my throat's getting kind of dry. All right, step 5. Using the console log syntax, output the value of my secret var and copy and paste the value in the following variable my secret var was. Okay, so there's two different ways we can output this. We can either write it right directly inside our IDE. Okay, that's one way we can do it. Or we can just jump over to the console and output it directly into there. Either one is your choice. I'm going to write in the IDE just to show you something different. To write in the IDE, it's just console log. And the name of the variable was my secret var. And just to make my life a little simpler, because that's going to output it into that wonderful console that's currently filled with errors, which might make it very difficult to find it. So what I can do, remember how I can add like a list of things, right? So I'm going to add a list. I'm just going to add one item. Here it is. There, that works. That will be easier for me to find it. Often, even though console is technically console.log, I will often tell you to console log it. As like, if it's one word. And that's usually, that's always what I'll mean. Console.log. If I tell you to console log it. What does your console log say? Okay? Once you've done that, feel free to jump over to your console Let's go see if we can find that. Should be somewhere. Might have to refresh. Oh, it says my secret var is not defined. Let me jump back over. Doesn't matter. It should still say the console above it.
I'm getting my secret var is not defined.
Yeah, I get that too. So why don't we just type it right in here? My secret var. There we go. What's the value? 256. Let's jump back over. And we'll just make this equal to 256. That didn't work out so well. It wasn't as fun. I was hoping for more of a treasure hunt kind of experience. It was more like a dud. All right, and if that worked, we should be able to jump over. Well, this should show. Why are you not showing? My secret var was equals 256. Why are you not updating over here? All right, there's an issue there. I'll fix that later. Don't worry about it. Just write down exactly what I've done so that way you don't lose the mark on the lab. We'll do the next one though. Using the console log, output the array value of my secret R. I would recommend just typing my secret R directly in the console. And record how many elements there are in the following variable. Num of secret elements. So can somebody tell me how many elements are in that array? Yeah, Ben.
5.
5? All right. So let's make it equal to 5. Something tells me this thing is completely crapped out. Do I have a red error? I don't have a red error. That's really weird. It was working. Let's do let number of secret elements is equal to 5. So that's a brief introduction to console log, but just before we take the break, I want to actually explain some information about console log. So something you're going to hear quite often from people is that everything in JavaScript is an object. This is a classic line for JavaScript developers. Everything in JavaScript is an object. It's not entirely true. Most things in JavaScript are objects, right? You guys have worked with objects, right? You did Java. It's an object-oriented programming language. You use objects all the time, right? What are 2 common attributes of objects?
State and behavior.
What's that?
State and behavior.
State and behavior, yeah, for sure. Usually stored in what? State's usually stored in a variable. What are they called though, usually? Properties, right? Properties, fields, attributes, they have different names. Sometimes it's data members. If you're working with C++, they call them data members. And then what about functionality? What are those usually called? Well, yep, methods. There we go. So properties and methods, right? Those are 2 common things that objects have. Console is an object, meaning it has properties and methods, right? Log is a method that is on the console object. It's available to you through the console object. If you jump over to your console for just 1 second, and I'm going to clear this out so you can easily see it. This thing is extremely powerful because it can give you some feedback. It can give you some hinting, just like your IDE does. You know when you start typing something, it gives you a hint, right? If I start typing in console, notice that it's completing it for me. It's showing me what it's going to look like. So I can type in console, right? Now, even more interesting, if I hit dot, it will actually show me every property and method available to the console object. Hit dot, and look at them all. There's assert, clear, context, count, count reset, debug. There's tons of them. And you can scroll through them with your arrow key. There's log, right? The one that we've been working with. There's memory, profile, profile end. There is tons and tons of stuff available to you through this object called console. Now, I've been clearing using a shortcut on my keyboard. The shortcut I use is Command K. I think you can do it with Control K if you're in Windows, or it might be Control L. I confuse those two. You'll know because your cursor will jump to the address bar if you hit the wrong one. So you'll have to click back. But you can also do console.clear. And then this little F means it's a function. It's a method. So we need to make sure we add the parentheses. You add the parentheses, that'll execute it. Hit enter, and that clears your console for you. The three that we'll use in this class are console.log, console.dir, dir, and console.clear. They're basically the only three we'll ever use. All right, so why don't we take a 15-minute break? Meet back here for 7:32-ish, around there. Let's say 7:35. Gives you time to grab some food or whatever you want, even though everything's closed and you can't eat anyways, but whatever. You get the idea. Let's take a break. All right, cool. We're about halfway. That being said, most of this should go pretty quick, so it shouldn't be so bad. We're going to talk about nested arrays. You guys should be used to nested arrays, hopefully. The idea of a nested array is fairly simple. It's an array that is made up of a list of arrays, right? And interestingly enough, that list of arrays can also be made up of lists of arrays. You can nest as deep as you want, but obviously the deeper you go, the less readable your code becomes and the more difficult it is. Some people, when they first started out with JavaScript, they're prone to doing this kind of structure where, especially if they're coming from a strict language. A lot of people coming from strict languages do this, where they rely on the index number and able to keep data kind of together, right? This is not necessarily the best approach. Even in a strict language, this is not the best approach. Anybody want to give a guess at what would be a better structure to use for storing data like that? Objects. Objects are much better for data like that, right? Creating a person class and doing it that way is definitely easier for keeping your data together. Because the one issue with working with arrays, especially in this type of structure, it's very hard to make sure that if something gets popped in there or pushed into there, that it doesn't break our order, right? And we lose track of, Sally. All of a sudden, Sally becomes Sally Alto instead of Sally Struthers because somebody's inserted an extra record into the last names, right? Anyways, so that's a point. But nested arrays are common. You are going to see them quite often, and they are handy. The one thing about nested arrays is even though I'm talking about storing things in objects, you guys took PHP? Yeah? You worked with MySQL? Right? Everything coming back from MySQL is in an array. You knew that, right? Yeah. So when you get back your rows, they all come back as tabular data. All tabular data is in arrays. It's always arrays. That's how tabular data works. So you do need to understand how nesting works in order to work with it, especially if you want to loop through it and be able to spit those things out. So these data structures are not obsolete. They do exist. You will see them. You guys got MVC this semester? With what language? ASP.NET? Okay. Who do you have as a teacher?
Justin.
I don't know, Justin. What database are you using?
Hasn't picked one yet.
Oh, he hasn't picked one yet? Will it likely be SQL, or has he been talking about like NoSQL?
Probably SQL. I think
SQL?
we even have that, so it'll probably be whoever we all use.
Cool. Tell him you want to learn SQL. That's totally fine. But tell him you want to learn an ORM. ORM stands for Object Relational Mapper. What that essentially does is it takes the data from the database and it turns it into objects, which makes it a lot easier to work with, a lot easier to query. It's so much faster and so much simpler to work with. So definitely tell them you want to learn an ORM. I don't know if there's ORMs for ASP. I imagine there is. There must be. There is for every other model view controller system, so I would assume there is. The one that I like is Active Record. That's for Rails, PHP, and JavaScript also has an Active Record version too. They're fantastic. All right, so back to nested arrays. If you're working with SQL directly, it kind of does this kind of thing. Not quite as nested, but you will wind up with one nesting. They're common and they can be sometimes difficult to work with as they often require nested iterations, right? So if you have a nested array and you want to access the data inside your nested array, well, now you're dealing with nested loops, right? Nested loops can become very problematic. They're extremely inefficient too, right? Because for every iteration of the parent, there's multiple iterations of the children, and there's multiple iterations of those children, right? So for example, in this one, for every student, we iterate, 1, 2, 3 times. We'll iterate 3 times, 1 for each student. To iterate out each one of those records for those students, we'll iterate another 3 times, so now we're up to 9 iterations. And to iterate out the courses, we're going to iterate another 3 times, so now we're up to 27 iterations entirely. Right? It gets way worse the more students you have. That gets bigger and bigger and bigger, right? So obviously, multiple nested iterations can become very inefficient. So, like I said, this is our nested array that we're going to work with. It's predefined so we can access it directly. One thing before we move on, up here, I wrote somewhere this wonderful thing, this line right here. Console log, here it is. Please erase that. That's what's breaking our script. Because my secret var is defined after that, which causes it to blow up. So make sure you remove that, other words, the rest of our script won't run properly. All right, back to our nested array. So this is an example of a nested array. Accessing elements in a nested array can be problematic for a lot of people because you have to remember that you're at 0 index, right? So for example, if I want to access Bob in our nested array, the name Bob, then I've got to start at the correct row, right? So let's open it to the floor. How would I access Bob? What index am I going to start with?
0.
0? Okay, so 0 is going to put us where?
5, 6, 7, 8, 9.
That's right. It's going to put us at the numbers, but I want Bob. So what index do I need? Yeah, we need to start at index 1. And then what is my next index in order to access Bob?
1 again.
1 again. That's exactly it. So to access Bob, I would do it like this. Students, the name of the array itself, right? The first index number. So 0 is the IDs. 1 is the first names. That tells the interpreter, okay, go to row 1. Now I want to access inside that array the next index, which is Bob, which is index 1. Okay? I freaking love these things. I find them fun. I find it fun to go through and figure out the index, and I like to put them on tests. So just to warn you in advance. I love putting them on tests because I find them fun. Students don't find them fun. I find them fun. All right. Accessing Sally's info. So I want to access everything to do with Sally. So in order to do that, I need her student number. So to access Sally's student number, I'm going to start at line 0, right? Then I'm going to move to her number, which is the third one in. So that would be index 2, right? Because we're 0 indexed. Then I need to get Sally's first and last name. In order to get her first name, I need to move to row or index 1 in the main array. Then to get her last name, I need to move to what index? 2. Now I want her last name. What index am I moving to get her last name? 2. And what index am I going to access to actually pull the name? 2. Exactly. 2. So as you can see, it can get quite complex because if I want to access Sally's course, it gets a little trickier. So 1, I have to move to this index, which is index 3, right?
Yeah.
Then it's made up of nested arrays itself, so I need to make sure I select the correct array that has Sally's actual list of courses. So hers is the last one, which means I move to index 2. And then, if I want to grab the first course, I move to 0, which is music, right? See why arrays suck? And why it would be terrible to use arrays as just constant data structures? They're terrible, right? But, c'est la vie. All right. In the above example, you can see why arrays aren't necessarily the best for this type of data, but this is exactly how most tabular data is stored. The main difficulty with this is if we have a student that needs to be added in before Sally or perhaps after Dave, we would have to keep track of their index and write large algorithms to process changes like that. But what's the fun in having this structure if we don't at least challenge you to access some data from it? All right. This should hopefully work. I will do the first one with you. If it works, then you two, yeah, there's two of you. The rest of you can do the other ones, yeah.
The second one you have to point to Bob or else it says it's incorrect.
Yeah, I want his last name. You have to give it his first name.
You have to give it its first name?
Yeah.
Otherwise it blows up? Well, that's stupid. All right. So it's not Bob's last name we want. Turns out it's Bob's first name we want. All right. Okay, first, let's try. We'll do Dave's science grade together. Okay, so Dave's science grade equals. So I'm going to scroll back up so I can actually see the data structure, right? So I want Dave. So let's see. I'm going to start with students, obviously. What index do I need to access Dave's science grade? So what's the first index I need?
4.
4? Okay, let's try 4. 4, cool. And then to access his correct array of grades?
0.
0, yeah. And then to access his science grade? 1. So 401. Let's see if that worked. Yep, sure enough it worked. I've got 53. Go ahead and take we'll give you 3 minutes. 3 minutes to see if you can do the other 2 lines. Now, it was pointed out that you have to access Bob's first name, not his last name. So make sure you access Bob's first name. Jory, do it. Yeah. I find them fun.
I was skipping out of you when you were talking.
All right. Yeah, I find them fun. So if you're kind of stuck, just take a look at that data structure, right? Notice where Bob's first name is. I know it says Bob's last name, but I goofed. So it's Bob's first name. We're starting on the second row. Remember, indexes always start at what number? 0, exactly. So make sure you choose the correct index, and then Bob is the second one in. Okay? All right. Let's. I'll start you off. There you go. What's my first word? That's right, students. What index number am I going to start with? Anybody want to give a guess? 2? What? Okay, how many people say 1? How many people say 2? All right, we're going to go 1 just because the masses are speaking. And then what index is Bob's in? 1. So we're going to say it's 1, 1. Let's see if we're correct. Yes, we rock. Bob's last name equals Bob. That's the dirty lie. I know. I made a mistake. So we're pulling Bob's first name. I think you missed it when I said it's switched to his first name. All right. Access and store Bob's geography grade. That one's a little trickier. You're going to wind up with 3 numbers, right? So I'll start you off. Okay, Tran says 4. 4, Tran? Yep. 1 and 2, you said? So 4, 1, 2. Let's see if you're correct. Yes. And that's better than I did in geography. Grade 9 geography, I got 50. And I think it was because the guy didn't like me. What's that?
I got 51.
51? I must have did something special. Yeah, I got 50. He didn't like me at all. All right. Like I said, I like to put these on tests. I find them kind of fun. I don't put many of them because they can be tedious. I only put like maybe a couple. But yeah, and I find it necessary. And I usually put them in one line too. So it makes it a little trickier to find it. But yeah. Okay. Let's talk about adding and removing array items. Now you might see my little emoji character. You might not. Depends if you have that character set. Or your emoji character might look a little different. But hopefully this tells you how I feel about this statement. Everything's an object. Because in JavaScript, not everything is an object, despite that people want you to think that. This is a bizarre learning path, but it is important to understand a basic JavaScript concept. Most things in JavaScript are objects. Most things that you're going to work with in JavaScript are an object, meaning they have two things, properties and methods available to them. Okay? It's an important concept to understand because you're going to be working with these often, even when you don't even realize you're working with them. You've already been working with them. You didn't even know. This is important to understand early so you're not caught unaware when we attempt to access methods or values on our objects. Okay? I'm going to use the terminology properties to describe values in an object and methods to describe functions in an object. And you may be like, that's kind of a weird thing to say. The reason why I'm saying that is because JavaScript doesn't actually have methods. JavaScript has properties, only properties. That's the only thing it has is properties. However, properties can be any value. They can be a Boolean, they can be a string, they can be a number, they can be an array and an object. They can also be a function definition, which makes them like a method. Okay? It is important to understand the difference, and if you understand that difference, it'll make you a very powerful JavaScript programmer once you realize that functions are just definitions. It's the parentheses operator that makes them execute, which means you can pass these things around all over the place without executing them until you're ready. Very, very cool, very, very strong. All right. The reason why I bring up objects is because we're going to talk about array lengths. And in order to talk about array lengths, we need to access a specific property on our array, which might confuse you when you go to access it because the array is just an array. No, it's technically an object. It's something that we're working with. Okay? So knowing how many items, elements are in an array is an important concept, right? Especially when working with dynamically sizable arrays like we have in JavaScript. Because it's not a strict language, because you're not predefining how many elements are in your array, you're often going to need to determine how many elements are actually in the array. That's where length comes in handy. Length tells us how many items are currently in that array. As said before, most things in JavaScript are objects. That applies to arrays. This means that array values have properties and methods available to us. If we want to quickly see a list of those methods, we can simply start with the array structure syntax and press dot in our console, and we will see a list of properties available or methods available to that array. So why don't we do that? So I'll open up a little console window here, expand it out. I'm just going to clear it and zoom in a bit. Go away, Prism. All right. Here's my square brackets, right? That's my array syntax. Okay? And I'm going to press dot. And there we go. Right over the massive list of different properties and methods that we have available to us on that particular syntax. I can see the length. And you'll notice it also shows you a little preview, right, of what the value is going to be. It's empty, so it's going to be 0, right? If I wanted to test against that, I could go 1, 2, 3, 4, dot. And you can see now it says 4 as the preview. There's length. There's concat. Notice the difference between length and concat. Length shows the value of 4. What does concat show? An F. Yeah, exactly. And the F means function. It means it's a function definition. It doesn't mean we're executing it. It just means it's the definition that is currently the value of concat, which is kind of neat because you can actually spit out its function, right? It says native code because it's a part of the library and they don't just spit out the actual code block for you. But suffice it to say that that is just the function definition. We didn't actually execute it. If we wanted to execute it, we'd have to add the parentheses in order to execute it. Anyways, let's go back to length. So there's length, there's concat, there's constructor, there's copy within, entries, every, fill, filter, find. There's a whole whack of these. And majority of these are known as iterators. What an iterator means is that it will actually process over each of the elements. Okay? We're going to look more in depth next week when we talk about functions. We're actually going to play around with a bunch of the array iterators, so you get an idea of how they work. They're just a little complex. But for today, we're going to keep it nice and simple. The three things we're going to talk about today is length, which will give you back the size of the array. We're going to talk about push, which is a function for adding elements. Pop, which is a function for removing elements. Unshift and shift, which are the same as pop and push, but they remove from the beginning and add to the beginning. And the last one, splice. Those are the five we're going to talk about. That's it for today. All right, let's use length, because length is fun. Let's move this over here. All right, so as I said before, knowing how many elements in an array can be handy, especially when we want to actually loop over those elements, right? You kind of need to know how many are there. In other words, you're looping for some arbitrary amount because you don't know how many are in the actual array. So we want to be able to loop efficiently. We only want to loop for the number of items that are actually in the array and then get the hell out of there, right? That's the whole idea. Be efficient with your code. So when we access an array size, the way we access it is by just appending the property .length onto the name of our array. So as you can see in the example, let my r is equal to Bob, Sally, and Dave. And then in order to access how many elements are in my r, we just do my r.length, and that returns back 3, which is the number of elements that are actually in the array. Why don't we actually play around with this ourselves? Come down here to step 10. How many elements does the students array have? Well, that's the students array that we were working with before, right? So all we have to do is type in how many elements it actually has. Can somebody tell me how many elements the students array has? Is it 4? 5? So we'll type in 5. And sure enough, that's correct. Is anybody confused by that? Looks like it has more than 5, right? Looks like it has way more than 5, because if you look at the actual structure, right? I mean, I don't want to actually count it. Well, it wouldn't even be that hard, right? 3, 6, 9, 12, 15, 18, and then another 9, which would bring us to 27 elements in there all together. Does anybody know what's happening when we call .length? What's that? You're on the definite right track. It's only doing what's known as a shallow count, which means it starts from the root and it counts the number of items in the root of the array. If I want to know how many elements are in these, I actually have to step into the array using like the 0 index, for example, and then call .length. And if I want to find out how many elements are in here, I'm going to have to step into students, index 3, and then I'm going to have to go to index 2, and then I'm going to have to call .length in order to find out there's 3 elements. So .length is a shallow count. It's important to understand that. So let's, step 11, using .length. This brings up that exact example. Using .length, how many elements does the student's first name have? Now you could cheat and write 3, and my script isn't going to know that you did that. It's just going to be like, cool, right? But let's try to play this game a little properly, be ethical. So how many elements does the student's first name have? So let's do equals students. And what index number am I accessing here? 1, yeah. And then what property we're going to use? .length. There we go. Remember I showed you JavaScript doesn't care if you move your array list items to new lines? When you start working with these properties like this, it can lead to several of these in a row because you can do something called chaining, where you call .length, then you call .sum, and then you call .something else, and whatever, and you keep going, and you have this chain of methods that you're constantly passing the value to. So what we can do to make it a little bit more human readable, bring your cursor to that dot, hit enter, and tab it in. And if you save, you'll notice it doesn't break the logic. Right? This also kind of illustrates why we use semicolons to tell it where to end. Okay. Cool. Step 12. Using dot length, how many elements does the student's course list array have? All right, so equals students. What index number is the course array at? Whoa, there's a whole bunch of answers at once. I thought somebody said 28.
It's 32.
It's 32. That'll put us off the chart. All right, so we're going 0, 1, 2, 3, right? So we're into 3. And we want to know how many does the course list array have, so that didn't ask us to actually drill down any further. So we're just going to do dot length, right? And like I said, we can put dot length on the next line if we wanted to. And if that is correct, we should see, yep, let num students courses equal 3. What's that? Sorry, I'm slightly deaf in my left ear. Yeah. But 3, 4, and 5. Yeah. Right, so if you come back here, so a couple of syntax errors. One, these spaces are not aligned because they're actually right on the space. They have to be buttered on this. Yeah, so that's the first thing. The second thing is, this is going to attempt to access the third index, right? We should put you on line. Yeah. So that'll put you on subjects. 0. No, unfortunately not. So what happens is 3 will put you into here. Then that's 0, 1, 2. That's how that works. No, so you're at 3, then 4 will actually be which one you want to access. Yeah. 0, 1, 2. Because the nested arrays start with those. No, because that assumes you're into a fourth array. So this is the array of the first one you're accessing, and this is the index of the second array that you're accessing. That's the idea. And this is the array that you want to access that one, and this one going ahead and go to one nested inside of that one, which the best array is. So 3 is going to put you subjects. 0 will put you on this first row. And then you're going to go which will literally count the then you want to step out to 1. Yeah, you want to go back. All right, so we've gone through, we've got our number of students now, we're able to use length. Interestingly enough, actually this is a good point, length, remember how I told you in week 1, JavaScript has strings, right? And strings are the data type that encompass both characters and strings, right? And then I said to you, in C++, there are no strings. They only have characters. Okay? In order to get strings, you have to actually include a library. And then that library gives you the string data type, which is actually a character array. JavaScript hides all that. Makes it obfuscate, I think is the word I'm looking for. It basically hides all of it so you can't see it and says, you have string. Just use string. But I can prove that it's a character array. If you open up your console, and I expand this, just type in your name, like so. And we can use our very handy dot length on it. The array method, dot length. And I get 14. Okay? I feel like that proves that the string is a character array.
Space would count, right?
What's that?
Space is counted.
It does. Yeah, spaces do count because they are technically a character. Yeah. Space is a character. Tabs would count because they are technically characters. New line also counts because it's a character as well. Yeah. Just to keep that in mind. All right, cool. So, I mean, what's the point in having a dynamic array if you can't add new elements into it or take elements from it, right? I mean, we might as well just go back to a strict language if that's the case. We want to be able to add items dynamically to our array and remove items dynamically from our array. And in order to do that, we're going to need some methods that will allow us to add and remove items. Okay? Like the property length, arrays also provide methods for adding and removing elements from an array. Being able to add elements to an array is what makes our arrays dynamically sizable. We have two common ways for adding elements to an array. Actually, there's three. That's a misprint. There are three common ways for adding elements to an array. The first one is quite simple. The first one is known as push. Okay? Many languages actually use push. If you ever use C++, it uses push. Push is what it knows. Ruby uses push. JavaScript uses push. Or sorry, not JavaScript. PHP uses push as well. Push is a very common one for adding elements to an array. Is it push in Java when you want to add an element to a list? No? I don't know what it is then. But it is push in many other languages. Push basically means take the value that I'm passing as an argument to push and add it to the end of my array. Okay? So, I will show you what I mean. Why would I do no example there? Wow. That is silly. Let's do steps 13 to 17 here. We're going to start off with using push, add the following three numbers to the array. So push allows us to do a couple of things. We can add one singular element if we want to, or we can add multiple elements. All we have to do is pass a list of arguments to push if we want to add more than one. So to use push, we'll use init r, our array that we're working with here. Okay? And we're going to say dot push. Okay? Push is a function, so we're going to use parentheses on it. And push takes a single argument, though it can be a list of items. Okay? So, we're going to say it wants the numbers 4, 5, and 6, so we just do 4, comma 5, comma 6. And that will put 4, 5, and 6 into our init array. If you want to double check that, open up your console, type in init r, and you will see 4, 5, and 6 added to the array. Now push adds to the end of the array. Okay? So if we were to call push again, it would add another number, but it would tack it on to the end after 6. Sometimes you want to add to the beginning of an array, right? Not necessarily to the end, but actually put something onto the beginning of your array instead. Maybe you're doing jobs, right? You're running a server that's going through jobs and you want one to take priority. So you want to add it to the top of the list so it becomes the next one that gets used, right? There's several different reasons why you may want to actually add to the beginning of your array. In order to add to the beginning of an array, we use the method unshift. Unshift will actually take an argument. It will take a list of arguments if you want and add them immediately to the beginning of the array in the order you added them. Okay, so we can do that. We do init r dot unshift, and the two values we're passing this time are 7 and 8. Make sure you don't quote those values. Quoting those values makes them strings. And when you try to add a string to a number in JavaScript, you will get a concatenated number back. Math in JavaScript can be weird. Now, there are times where you want to actually remove items from an array, right? If you can add them to an array, you should be able to get them off the array. In order to remove items from an array, we have two very common methods that we use, pop and shift. Pop removes from the end of the array. So let's do that now. We're going to init r dot pop. Pop doesn't take an argument. Yeah.
I'm not sure if it's.
Just ignore the envelope currently.
Do we have to put like square brackets after this to make it? Because I'm getting.
Oh. Yes. No, we do. Sorry. Yeah, you're right. We have to make it equal to an empty array. Yeah. So on line 74, make let init r equal to an empty array. Yeah, you're right. We're trying to call push on an undefined.
You have to actually initialize it as 1, 2, 3 for the whole thing.
Yeah, I couldn't get it.
How the heck did I miss all that?
Well, you had it in there in your example, but.
Yeah.
Then I must have deleted the whole damn thing. All right, initialize it with 1, 2, 3 as the values in there. Jesus. Pay closer attention. It was kind of a long weekend, and yeah. Like these things take like almost 12 hours to put together for a 3-hour class. Yeah. All right, so we'll initialize our array with 1, 2, 3 in order for this to work. We're going to push on 4, 5, and 6. Then we're going to unshift 7 and 8. So at that point, your array would be 7, 8, 1, 2, 3, 4, 5, 6 would be what the array's value would be at that point. On step 15, we're going to pop, which comes from which side? The beginning or the end? Yeah. Which means what number's going? 6. Yes, exactly. 6 is gone. Not 8. 8's at the beginning of the array, right? If we use shift, that's how we can get elements from the beginning of the array. If we do init r dot shift, it'll pop off the 7 at the beginning of the array, and we'll lose the 7. I think, actually. Yes, I was right. I doubted myself for a second because I wasn't sure if it would add 7 and then put 8 on. So it would have been 8, 7, but it doesn't. So we've popped, we've pushed, we've unshifted, we've popped, and we've shifted. Sounds a bit like a porno. We've interacted with this array. We're feeling a little dirty and grungy at this point. Step 17, we're now going to use something that gives us a lot more control over what we do with elements in our array. It allows us to put elements in specific spots and remove elements from other spots. We can remove blocks of elements from spots. We can put in multiple elements into spots wherever we want within the array. Splice is fantastic, but Splice is destructive. What I mean by that is it will modify the original. It will not create a duplicate of it. It will not clone it. It will modify the original and do destructive things, including delete elements that are in your array, or add elements in your array. Either way, both of those are considered destructive operations. Okay, so just keep that in mind when you're using Splice, that it is destructive. So, Splice is an interesting method that allows you to add or remove elements from an array at any point in the array. For example, adding a new element to an array between the first two elements. So as you can see from the syntax example, I have Sean, Dave, and Sally, and I want to add Frank between Sean and Dave. In order to do that, I use Splice, and then I give it 3 arguments. If you scroll down, where did I put it? I had the thing. Oh, it's gone. It's disappeared. Fantastic. Now it's just an empty note character. All right. Guess we'll use the blackboard. So here we go. We have dot, Splice. Argument 1 is the index we want to start at. Right? So if I want to start at the beginning of the array, what will my argument be? 0. Exactly. That will start at the beginning of the array. Okay? Argument 2 is how many elements do you want to delete? See why it's destructive? So if I don't want to delete any elements, then I'm going to give it 0. If I want to delete one element, then I'm going to give it a 1. Okay? But I don't want to delete any elements, so I'm going to say 0. The last argument is a list. It's a list of things you want to put in at that spot, at that index that you are currently located at. Okay? So if I want to add in Frank, I add Frank, and then I close. Index to start at, number of elements you want to delete or remove, elements you want to insert at that index. All right? So, let's practice one. Step 17. Using Splice, add the number 256 between the numbers 2 and 3. Okay? So in order to do that, it wouldn't hurt for us to see what initR is currently. Okay? Let's open up our console. I'm just going to detach my console because it makes life a lot easier for me. All right, let's take a look at initR. Okay, and we want to add it between 2 and 3. So let's take a look at this. I'll erase out these arguments. All right, I'll do comma, comma. We know the third one will be 256. How many elements am I deleting? 0. Right. What index am I starting at? 3? Okay, we'll say 3. So let's type that into our IDE. All right, so we're going to go init r.splice. Okay. And it even comes up and tells you, your IDE should come up and tell you and what the structure is, right? So the first thing is the index we're starting at, which is 3. The second will be the number of elements we want to delete, which are 0. We don't want to delete any elements whatsoever. The last is what we want to add to that location, which is 256. And then we can save it. If you did it correctly, all of our code should spit out on the left-hand side, and you should see all good at the bottom of it. Incidentally, under the hood, it's actually adding all the numbers together to make sure they equal the correct amount. We're actually almost done, so it's up to you. Do you want to take a break, or do you just want to power through and we'll be done? Cool? All right, we'll power through. The last little bit here is going to be fairly, it's going to be definitely pretty recap for you guys, review, because I'm sure you've written enough loops to, bend space. let's talk about it either way. Any questions about splice, pop, shift, unshift, or push? I almost forgot them all.
Is Splice more, is it a more expensive operation?
Definitely, yeah. Definitely more expensive because it has to take your index, find the correct index in the location of the array, which means it iterates to get there.
Yeah.
It inserts, copies out the whole array, and repositions everything in the array. Only if you absolutely need to insert at that specific point. Yeah, definitely. Splice is a lot more costly. That being said, JavaScript's asynchronous and everything moves stupid fast. But if you get a large enough array. All right, let's talk about loops. Loops are important, right? We need to iterate. I mean, we have these wonderful arrays full of lists of items. It would be very nice to be able to iterate through and see those items and their actual values, right? And that's where loops come in handy, but that's not the only place. Did I tell you guys I went to university for game development? I didn't complete it, so don't get excited. Loop. Most common thing in every single video game is the game loop. The game loop is literally an infinite loop that runs constantly. And as it's running, it's evaluating a bunch of different things, right? So you've got Nathan Drake on the screen, and you've told Nathan Drake to move forward, and in a flash of a microsecond, the game loop goes through its iteration and tells Nathan Drake to move between X and Y at this distance, right? And so Nathan Drake moves. Now I'm oversimplifying it because it's not just doing that. It's also calculating all of the movement in his arms, his legs, his mesh movement. It actually changes the deformations of the vertices in his arm, the deformations of the vertices in his leg, and it's moving all of that through very fast math on your GPU. Your GPUs are fantastic at math. They're way better at math than I am. Now, the game loop is important. It's an infinite loop. We don't generally want infinite loops, right? Because infinite loops tend to be bad, right? They usually lead to our browser crashing in front of us. But in game development, yeah, you do need an infinite loop because you're doing so many things at once. You need to do calculations every single iteration. The game loop generally is a while loop. That's usually what we use for game loops or while loops. So we have two kind of while loops that we can use. We have the while loop and we have the do while loop, right? Does anybody know the difference between the two?
One operates before, one operates after.
Yes, one operates before, which means it will execute the code inside the block, regardless of if the condition is true or not. The other one, the condition has to be true for it to execute the code inside the block, right? So while this condition is true, execute this code. That should tell you right off the bat. That's the one that needs to evaluate the condition first, right? While this condition is true, execute this code. Do this code while that condition is true. Which means go ahead and do this stuff, and then we'll check to see if it's okay later, right? That's how I usually do things with my wife. I just do it and then ask permission later. Get in trouble later, right?
Are you still married?
Yes. I don't know what time is it. All right, so we're going to write a while loop. Now, my wonderful evaluation code unfortunately can't read your syntax yet. It's coming. Still trying to figure it out. So you just have to kind of take advantage that it's going to evaluate your value, right? So it's going to basically look to see if your value is X or whatever, and then it will do that. But hopefully by next week I'll be able to do evaluate your actual code itself. All right, so in the example here, I'm using a sentinel variable. Sentinels are quite common. You guys heard of sentinels before? No? Sentinels are ways for us to tell whether or not something is done. We use it like a toggle, like a flag. Sometimes they're called flags. A sentinel basically allows us to be able to exit the while loop when we can, right? Because otherwise the while loop will literally go forever, right? Unless the condition is met. So we're basically saying, well, sentinel is less than 10. So sentinel is currently 0, right? If I do nothing with sentinel in my loop, it will always be 0. It will never change, which means we'll literally loop forever. Till the end of time, till you run out of memory, to whatever. So we increment sentinel by 1. How many times will the while loop iterate? 10 times. Yeah, 10 times. We start at 0, then we add 1. That's one iteration right there. And we keep going until we get to 10, and then we'll exit. So we'll iterate 10 times. So Sentinel's value will be 10 when we're done. The above code will iterate 10 times, adding 1 to Sentinel each time. While loops only execute if the condition they're evaluating is true. The do while loop's a little different, right? We have the Sentinel equal to 10. We're going to add 1 to Sentinel while Sentinel is less than 10. How many times will the loop iterate? Actually, better question. How many times will that block execute? Just one time. Absolutely, just one time. Because Sentinel is already 10, right? So while Sentinel is less than 10, execute this thing. Well, Sentinel is not less than 10 because Sentinel is 10, right? But the do says execute this one time, which makes Sentinel worth 11. If you find that confusing, I recommend playing with do while loops and while loops so you get familiar with how they actually work, because they are kind of cool. We're not going to build, that's not true. We are going to build a game. We're going to build a tic-tac-toe game, and we will be using a game loop. Just, that's in the future, though. It'll be simple. Don't look so nervous. It's really, really simple. Actually, I can show it to you. The one that we're going to build. Just ignore that. We're going to build this one. See? Click. Oh, it responds. Click. Ooh. That's because it's got AI inside of it. That's a lie. It's not that smart. See, I won. But we're going to build that. All right, so while loop is very important, and we are going to make one. I have an example here. Yeah, step 18. Write a while loop that increments the Sentinel 8 times. All right, we can do that. We already have our Sentinel value, so I need to write while, and what will be my condition? Sentinel is less than 8, yep. And then Sentinel, and you can increment in 2 different ways, actually 3 different ways. You could do it this way. But that's, my God, right? We can shrink that up a little bit. We can do it this way, plus equals, right? That's a little better. But I mean, we can lose some other characters, and we can just do plus plus. That also works. Incidentally, if you want to decrement, it's minus minus. And if that worked, you should see it spit out to the left-hand side. Now we're going to write a quick do-while loop. Write a do-while loop that increments the Sentinel 2 more times. So we're still using the same Sentinel, right? Only this time we're going to increment it 2 more times. So, well, the inside code will be the same. But what is my while condition this time?
Sentinel is less than 10.
Nice. Yep, while Sentinel is less than 10. That'll get it to iterate those 2 more times. For those of you struggling with it, 10 minus 8 equals 2. Cool. That's while loops and do while loops in a nutshell. We will be using them a lot more often. All this stuff is just foundational knowledge, right? For loops. We use while loops generally when we're not sure how many iterations we need to complete. That's why you tend to use while loops when you're going through record sets, right, from a database. While loops if you're going through data that you're not entirely sure of, or an API call, anything, or you just want to loop infinitely. You tend to use while loops when you're not sure how many iterations there are that you're going to complete. If you know how many iterations you're going to complete, we generally work with for loops. For loops tend to be better for set number of loops that we want to execute. So the most common for loop is the one we're going to write here, though JavaScript does have 3 different for loops. Okay, this one is fairly common. And its syntax, I did outline here so you can look at it. You can actually hover over these things, and it will tell you what each of these means. Right? So the first thing is the command, which tells the interpreter we're going to iterate. It's the for command. The second is known as the initializer. It's your variable that you're going to start with, right? So generally we call it I, but sometimes it's J, sometimes it's K. It can be whatever you want. You can call it Tommy. It doesn't matter. Then we say if I is less than 10. So if this initialized variable is less than 10, this condition will evaluate every iteration. So every time we go through, every time we loop, it's going to evaluate whether or not I is less than 10. So obviously, I needs to change. I needs to modify in some way. The cool thing about for loops is the third argument is our incrementer. It's what tells I to increment each iteration. So every time we go through the loop, it will execute the end expression. Ready to have your mind blown a little bit? That's just an expression. You can put anything you want there. You could run a function there if you wanted to. Anything you want to do to I, you tell it to at that point. Okay? So for those of you that are a little bit more advanced in programming, there's a lot of power in a for loop. You can do a lot of cool stuff with for loops. Anyways, a little bit more simpler. Not only can you only increment, you can also decrement, right? So you can increment or you can subtract numbers if you wanted to. All right. The last piece is the block. The block that you're going to execute, right? It's the logic that you want to execute on every iteration until the condition becomes false. Okay? Let's write a for loop. So write a for loop that adds 0. Am I missing anything? Adds 0 to 10. Oh, we're adding a range. So we're going to add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until we get to 10. And obviously we don't want to do that manually. First, we'll set the initializer. Let I equal 0, right? I mean, like I said, it doesn't have to be I. It can be literally anything you want. Call it Tommy. Call it butt. I don't care. Whatever dirty word you want to use. All right? Just don't use spaces. Abide by variable naming. All right, the next piece is the evaluation. If I is less, almost did it, less than or equal to 10, because we want to include 10 in our equation, right? Yeah.
Could you also just put 3 equal signs?
Can I put 3 equal signs here?
Well, no, like.
No, because if you do, if I is equal to 10.
So it does not equal 11.
Yeah, you could do not equals 11, or you could do equals 10. I think there's a reason why you don't do that.
If it skips it, then you're stuck in there.
Yeah, it's because if it misses it, for whatever glitchy reason, it would go forever.
Yeah, but wouldn't it, if you have it equal to 10, then it wouldn't execute.
Oh, yeah, no, exactly.
It's not correctly set.
Yeah, wow, long day. Yeah, because that will never execute. Yeah, fantastic. However, you are right. If it doesn't equal 11, it would work. Because it doesn't equal 11 until it gets to 11, and then it would equal 11. So that would work. But you want to do less than equal to or not equals to. I've never seen anybody do that one, though. I don't know if there's any benefits to that either. I feel like there's no benchmark benefit to that.
On if it did not equal 11, it's skipped that. That would say
Yeah, it would. But the likelihood of it skipping it is like not very likely. I want to say it's impossible.
But
Yeah.
you run over that multiple times, in which case
Yeah.
it runs over it 1,000 times a second.
Unless you're incrementing by more than 1.
The only time I've ever seen goofy things like that happen is using for each loops. For each loops sometimes won't iterate correctly because they run asynchronously in JavaScript, and they can cause problems that way. So, because you can have one thing set the number, and then another thing set the number, and then all of a sudden it screws up the whole equation. Yeah. All right. So, anyways, the first one's the initializer. Let I equal 0. The next one's the conditional check. Is I less than or equal to 10, which is going to evaluate every single time it iterates, right? The reason why we're doing less than or equal to 10 is because we want to add from 0 to 10. If it's less than 10, the second it hits 10, it's not going to execute that block, which means 10 won't get added on, right? The last piece is our incrementer. We're just going to use an I++, just a very simple incrementer. Okay? Then inside here, we need to add it. So the best way to do this is for loop value plus equals I. That's just taking I and adding it on. Right now it's 0. Next time it iterates, it's going to be 1. Next time it iterates, it's going to be 3. The following time it's going to iterate, it's going to be 7. Or sorry, 6. And then it's going to keep going till it reaches 55, I think it is. Is it 55? Yeah. That equation is called something. Don't ask me what it is. Is it the Fibonacci? I think you're right. It's not Fibonacci?
No, that's adding everything. A
Oh
special
yeah,
check
you're right. You're adding the previous number to the current number.
Yeah, to the current number. I don't know what it's called.
Not equaling.
It's a thing.
Yeah,
It's a thing. I don't know what it's called, but it's a thing.
Fibonacci is like when you add the numbers that can't be divided by anything else other than itself in one.
Oh, so only adding prime numbers together.
Yeah.
Right. I think we wrote one of those in university, but I was terrible at math.
I know, it's not on YouTube.
All right. So this for loop is very common. However, it's not necessarily the best loop when it comes to working with arrays. However, we can use this for loop to work through an array. And this is kind of where it comes in necessary to use the length, right? Because we want to know how many times to iterate. We don't want to just iterate indefinitely or some arbitrary amount, or we'll miss values. So what we do is we go for, we set our initializer, right? And then I'm going to do I less than, right? And what am I going to test against? I only want to iterate the number of times there are elements in the array. Yeah, so xr dot length. Yeah.
I think you meant for this to be a for loop.
Don't jump ahead. No, I meant this to be this loop. Oh, yeah, no, you're totally correct. All right, we're going to do it both ways. We're going to do it both ways. I meant to write an example for the other one. All right, then we're going to increment I++. Anybody want to give a go on why I'm doing less than xr.length and not less than xr.length plus 1? What's that? Right. And what am I taking advantage of matching up to the index number? I, right? Because I is going to match up evenly to that index number. The first time we iterate, I is 0. The next time I iterate, I is 1. So I can literally pinpoint that up to my array. So it makes it very easy. When I want to add all the elements inside this array, I can just go for of loop value plus equals exr and pass it the index number, only I'm not passing it a hard-coded index number. I'm just going to shove I in there. And if it works, you should see the code on the left-hand side, which it did. But as this gentleman pointed out, what's your name? Nick. As Nick pointed out, we actually want to write a much easier loop here. One made specifically for arrays, known as for of. For of was introduced in ES5, which is the ECMAScript 5 standard. So JavaScript has these standardizations that browsers try to abide by. Okay? We have multiple browsers, as we found out today. People are using Opera, right? There's Conquer, right? There's all these different browsers. When they implement JavaScript into their browser as part of their browser API, they choose a standard. When they say, yes, I will use that standard, that means they must abide by what the standard specifies, which means if you're going to use the ECMA 5 standard, you must have for of loops, you must have for in loops, you must have let, you must have const. Those are things that you're required to have. You can't leave things out, you can't pick and choose things, but what you can do is implement them in your own way. So underneath the hood, how let operates in Firefox might be completely different to how let operates in Chrome. They could operate entirely different. Incidentally, just out of curiosity, how many of you have heard of OpenGL? A couple of you? How many of you have heard WebGL? Any GL, right? Does anybody know what OpenGL actually is? So a lot of people think it's a language, but it's not. OpenGL is a standardization, just the same as working with ECMAScript. What OpenGL says to the graphics card company is you're welcome to use our specification. You're welcome to say that you are OpenGL compliant, but that means that you must have MAT4s, VEC4s, you must have all these different math implementations inside your graphics card and make them exposed to the front-end API. Those are standardizations, not languages, standardizations. Okay? So let's write a for of loop and then we'll call it a night. So we're going to just do the same thing, but in order to do the same thing, I want to reset for of loop value. So I'm just going to make for of loop value equal to 0. Notice I don't use let in front of it because we've already defined it. If you put let in front of it, it will blow up and tell you it's already been defined. So we're going to reset it. We don't need to reset the array because we're just reading the array. In fact, we could have made the array a constant because we're not changing its value. So now we're going to write our for loop. It's for. And inside here is a little bit of different syntax than what we're used to there. We still need an initializer, so we're going to call it let. And we can say I. I tend to not do that because it's a list of elements, so I like to do L. I mean, you can use I if you want. I don't really care, but I tend to do L. And the cool thing about this, the beauty behind this, is the readability. Sounds almost Shakespeare-ish. Let L of XR, well, maybe more techie than Shakespeare, but whatever. You get the idea. What this basically says is for every element inside our array, assign it to L. Now L is available to us in the block, and we're just going to go for of loop val plus equals L. Very clean, very readable. I definitely prefer for of loops over the standard for loop when you're working with arrays. And if it worked correctly, this should not change. That should stay the same. One last thing before you go. There's also a thing called a for in loop that you may find on the internet. Do not confuse for of with for in. For in will not work with arrays. It is specifically for objects. And that's it. Any questions before you guys dodge out? Yeah, Ben.
It was actually right. It's Fibonacci.
There you go. It is a Fibonacci. He still doesn't agree with himself.
If you add the previous two numbers together, then it is keeping that forward.
Right. That's what we did. That's what we built. Yeah. Cool. I will